In less than 15 years, if we are to trust what is being claimed, our dream of going to Mars will finally become a reality. At least 6 astronauts will descend somewhere on the surface of the red planet, where they will spend up to several hundred days building a base, exploring the surroundings, and producing rocket fuel. At the end of their stay, that rocket fuel will power a Mars Ascent Vehicle, which will return those early pioneers to the deep space habitat and then back to Earth. All beautiful and exciting, and yet, doesn't it seem to you that this big picture is still missing something? Everything seems planned, but what will be the landing site? It hasn't been said, it's not discussed. Why? In the depths of Valles Marineris, there is ice, water, and maybe life. Don't think, however, that this small detail has been deliberately neglected. On the contrary, since the planet has been put under siege by orbiters and rovers, paleontologists do nothing but accumulate data that can answer that very question. A question that calls for increasingly accurate knowledge of a host of factors, from the average wind speed in the region to the roughness of the terrain, from temperature to atmospheric pressure. Rocky terrain can damage spacecraft, and sloped areas could cause them to tip over. In 1996, when NASA was evaluating landing sites for the small Sojourner rover, it was still using data from the Viking missions, the first orbiters to reach Mars in the mid-70s. The smallest object the Viking cameras could report was the size of a soccer stadium. Today, the Mars Reconnaissance orbiter, which has been orbiting Mars since 2006, can detect rocks smaller than 1.5 meters. This will be a very important feature until the first human missions build the first landing surfaces. Moving on to the numbers, the preferred sites have an inclination of no more than 5 degrees per 10 linear meters, and a probability of less than 5% of landing on a rock at least half a meter in size. In addition, 2 decades of Mars studies and technological advances have reduced by 500 times the area of the landing ellipse, which is the region within a probe is expected to land, based on its trajectory as it approaches the planet. A smaller landing ellipse means engineers have created a more accurate model of the probe's predicted trajectory, and that means spacecrafts can now descend to Mars more accurately, even in regions that aren't as forcibly flat as they once were. In the future, the first human landing is expected to take place in a circle of radius equal to only 200 meters. In contrast, consider that the landing ellipse of the Curiosity rover, which arrived on Mars in 2012, measured 20 by 7 kilometers. The ideal site should also be at a maximum latitude of 40 degrees. Temperatures there remain moderate compared to the rest of the planet, which prevents hardware from freezing in a world where temperature differences between day and night are extreme. Solar-powered spacecraft will also have the greatest exposure to sunlight at the equator. The equator region is perhaps the most suitable location for humans, especially if they plan to return to Earth. Mars, also like all celestial bodies, rotates faster at the equator, which would give a rocket traveling in the same direction of rotation additional thrust, with associated fuel savings. NASA launches its rockets from Cape Canaveral for the same reason. Reaching Martian orbit from a region close to the poles would therefore result in much higher fuel consumption. It must be said, however, that the low-altitude requirement contrasts with the requirement for potentially resource-rich ice deposits, which exist in colder regions near the poles. Low-altitude sites are then preferred. Mars's very thin atmosphere is thicker in these areas, and spacecraft can use it to better slow their descent. More atmosphere to cross means more friction. More friction means to arrive at the ground with less speed, therefore to use less propellant for landing, therefore to be able to carry a greater payload. The last requirement, perhaps the most important and controversial, is that the chosen site offers the best chance of finding some form of life, even if it is microbial. Okay, but is there a place on Mars that can meet all of these requirements? From leaked rumors from NASA and SpaceX, it seems that at the moment, the best is Phlegra Montes, with a latitude of just over 30 degrees and an elevation of minus 3.2 kilometers. Clear indications of the presence of ice and acceptable size for surface rocks. Arcadia Planitia and Erebus Montes sites follow, characterized by an elevation of 3.9 kilometers, but at a higher latitude than Phlegra Montes, therefore further from the equator. Well, to tell the truth, nothing has been officially communicated yet, but what is sure is that a large number of paleontologists, when asked about it, never fail to give their preference to an extraordinarily famous site, which, however, is never or rarely mentioned in official studies as a potential candidate to host the landing. How come? We are talking about Valles Marineris. Hang on a sec, guys, before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. Valles Marineris, or Mariner Valley, so named in honor of the space probe Mariner 9, is a vast canyon system that runs along the Martian equator just east of the Tharsis region. Valles Marineris is 4,000 kilometers long and reaches depths of up to 7 kilometers. For comparison, the Grand Canyon in Arizona is about 800 kilometers long and 1.6 kilometers deep. In fact, the extent of Valles Marineris is as long as the United States, and it spans about 20% or 1/5 of the entire distance around Mars. The canyon extends from the Noctis Labyrinthus region in the west to the chaotic terrain in the east. Most researchers agree that Valles Marineris is a large tectonic crack in the Martian crust, forming as the planet cooled, affected by the rising crust in the Tharsis region to the west, and subsequently widened by erosional forces. However, near the eastern flanks of the rift, there appear to be some channels that may have been formed by water. In reality, we don't speak of a single canyon, but a system formed by a chaotic interlacement of more canyons and gullies probably dug by lava flows. Here and there are also some volcanoes, although small compared to the majestic Olympus Mons. These are more than anything else volcanic cones up to 400 meters high. Today, most scientists believe that the formation of the nearby Tharsis region may have contributed to the formation of the gorge. The Tharsis region contains several large volcanoes that eclipse those on Earth, including Mount Olympus, which at 25 kilometers is the largest volcano in the solar system. As molten rock was ejected from the volcanic area to form the monstrous volcanoes 3.5 billion years ago, the crust rose upward. The stress fractured the crust, causing large faults and fractures on the planet's surface. These fractures, growing over time, gave rise to the massive Valles Marineris. The fractures caused the ground to sink and opened an escape route for groundwater, which helped flood the fractures, sweeping away the soil as it flowed. Signs of flooding are especially evident at the eastern end. Water has reached the plains, creating a series of channels. Scientists still don't know if the flooding happened in a short period or if it was a huge flood accompanied by several other smaller events. Landslides also help widen the fractures, and lava flows and ash from nearby volcanoes may have played a role in the formation of this huge and fascinating feature of Mars. But what Alfred McEwen, planetary geologist and director of the Planetary Image Research Laboratory, believes to be the ideal site is in the eastern part of a gorge called Melas Chasma, located in the center of Valles Marineris. This depression reaches a depth of 7 kilometers with respect to the reference profile of the Martian surface, and almost 11 kilometers with respect to the lands that surround it. Its bottom hosts many large deposits of landslides, as well as layered materials and sand dunes. There is evidence of both water and wind action as a mode of formation for many of the interior deposits. Melas Chasma once contained large volumes of water, McEwen explained, and today it contains what amounts to large volumes of air on Mars. It boasts some of the highest atmospheric pressures on the planet, more than twice that of the planet's average. Much higher than average atmospheric pressure leads to 4 important advantages. First, fluids are not going to boil away instantly, and liquid water may exist in a liquid state for some period. Second, the colony will have enhanced protection from daily low-angle cosmic radiation. Third, the weather conditions will be somewhat more stable, as at the bottom of the canyon would not necessarily fall prey to the dust storms sweeping the surface. Fourth, if liquid water still exists at the bottom of the depression, it probably means that it has been there for a very long time, which would make that site an excellent place to look for residual Martian life forms. Combined with the abundant equatorial sunlight, this also means that on long summer afternoons, with that pressure, temperatures at the site could easily exceed the freezing point of water, reaching as high as plus 20 degrees Celsius. For all these reasons, Melas Chasma is mild by Martian standards. It is one of the most Earth-like places on Mars and the best for an initial colonization attempt. There is, however, one substantial obstacle. Despite all its geological riches, Melas Chasma has no water reserves to keep a crew alive and provide fuel for the return home. And it is for this reason, associated with the dangerousness of the landing linked to the great complexity of the terrain, that NASA has never seriously considered the hypothesis of Valles Marineris as the ideal place to land the first human expedition on the planet, and this despite the long series of indisputable advantages listed above. However, the situation suddenly changed in mid-December of 2021, when new evidence obtained by the Trace Gas Orbiter, a satellite of the joint European-Russian ExoMars mission, convinced almost all paleontologists that mixed in with the regolith from the bottom of Meles Chasma, there is a massive amount of water ice a meter deep, much more than we expected. To scientists, the presence of water on Mars is already known, especially at the cold poles in the form of ice. But the discovery of new underground reserves in a seemingly extremely arid planet is remarkable. In the specific case of the central part of Valles Marineris is a reserve similar to the permafrost regions of Earth, where water ice persists under dry soil due to constant low temperatures. The persistence of water remains a mystery, as pressure and temperature at the equator should prevent its formation, so scientists will now have to find more answers by analyzing the geomorphological conditions in Valles Marineris. After that, the permafrost could allow them to access potential life forms left just inside it. Water could also be chemically bound to other minerals in the soil, but from their observations, scientists lean more towards the hypothesis that it is present in the form of ice and are convinced that there is a special combination of temperature and pressure at Valles Marineris, which is still unclear, that allows water to be preserved or at least replenished. The possibility that, contrary to what was previously thought, water can be found on Mars even in the equatorial regions, warmer and therefore particularly suitable for human exploration, could change, and not a few, all the scenarios in play. Since most future missions to Mars will land not far from the equatorial regions, having identified such a large amount of water at a site of great potential like Valles Marineris is an exciting prospect for future exploration, especially for the search of habitable environments with possible signs of past and present life.